All right, boys and girls, so we are going to take a look at page 12, problems 6 through 11. These were the questions that we were going over. Our goal was to go over live today. And again, I'm having problems with my technology in my classroom and the refresh rate and keeping that up so that you guys are able to follow along on your computer. So what I may have to do is talk to parents and talk to you guys and see if this is a better way for us to go through the problems that you're doing independently in your book so that you can kind of check and make sure you're understanding all of these questions that we're asking you guys to do. So let's first look at question number 6. So the question is, what can you say about the threes in 43,862 and 75,398? So what I tell students to do, you notice that I just underlined the digit we're looking at, the threes. What I tell students to do is just write these one on top of the other. So I can first write the number 43,862 here. And again, I'm focused on the 3, and that 3 is in the thousands place. And right below it, I'm going to write the second number, making sure my place values line up. So the ones place is on top of the ones, the tens, the hundreds, etc. This one I'm underlining the 3, which is in the hundreds place. So now I'm able to do kind of what we did throughout this entire lesson, where I'm comparing the place value. So I'm looking at the 3 here in the thousands, the 3 here in the hundreds. And the question is, so what can you say about the relationship between these two numbers, focusing on their place value? So we might say something like the value of the 3 in, and we're going to first refer to this number because the 3 is in the greater place value here. I know that the thousands place is larger than the hundreds place. So I'm going to start with this one. The value of the 3 in 43,862 is 10 times greater than the value of the 3 in, now we're going to rewrite this second number, 75,398. So just to review from the video, we're able to do that because we have the same number, the 3, and then in this number, the 3 that's in the hundreds place. We know that when we move one place value to the left, we are increasing. It's 10 times greater. Let's take a look at question number 7. Mia says in 5,555, all the digits have the same value. So I'm going to underline, or I could even box in this number. And then I have to think about what Mia is telling me. All the digits have the same value. And then I also want to underline the question. Is Mia correct? And explain. So right away when I look at this number, 5,555, I can see that all of the digits are the same. They're all 5s. But when I think about the value, if I walk into a bank and I have 5 ones in my pocket, just 5 ones, but you walk in and you have 5, and that's in the tens place, so you have 5 tens, do we really have the same amount of money? No. I have $5. If you have 5 tens, that's like 10, 20, 30, 40, 50. then you have $50. So we do not have the same amount. So how can I answer this question? Because I know they're all the same digits, but they're definitely not the same amount. Then I want to first say no. All of the digits are the same, but each digit has a different value. Again, keeping that example in mind that I only have $5, but if Easton walks in and he has 5 in the tens place, that means he has 50. Again, not the same value. Let's look at question number 8. In 1934, there was an extreme drought in the Great Plains, meaning there was no rain and no water. In the number 1934 is the value of the 9 in the hundreds place 10 times as great as the value of the 3 in the tens place. Explain. Okay, so we are focused on this number right here, 1934. And we're talking about the value of the 9 in the hundreds place. And then we're also looking at the 3 in the tens place. So they're trying to trick you on this one, guys. Because if we look, we're talking about this 9 and this 3. And we know that when we move from the tens place to the hundreds place, we're increasing 10 times, right? It's 10 times greater. However, can we compare a 9 and a 3? No. These have to be the same number in order to say that they are 10 times greater. So, we might answer this question by saying, no, the digits must be the same for the value of the digit on the left to be, I'm going to squeeze it in, 10 times greater. So what does that mean? Well, let's take a moment. Let's go back to that example that I used earlier. And I said that, I'm going to move my whiteboard here. So the number 55. Ones place, tens place, right? I go into the bank and I just have 5. That means I have $5. But Easton goes in and he has a 5 in the tens place, so he has $50. This amount that Easton has is 10 times greater than what Mrs. Body has. Now let's try that with different numbers. Let's say, now we're looking at a 4 and a 5. Again, they're side by side, but does this rule that it's 10 times bigger still work when the digits are not the same, meaning these are not the same number? So now let's think about this same scenario. I go into the bank, I still have $5 because I have a 5 in the ones place. But now, Easton walks into the bank with 4 tens because he has a 4 and he's in the tens place. So he has a value of $40. Is 5 times 10 40? No. So now we can see that you do have to have the same digit there in order to make that statement that it is 10 times greater. Okay. Moving right along. Number 9. Vin says 4,346. Sorry, Vin says in the number 4,346 that one 4 is 10 times as great as the other 4. So one 4 is 10 times as great as the other 4. Is he correct? And explain. So I am going to highlight the 2 4s because those are the numbers we're comparing. I have a 4 in the thousands place and a 4 in the tens place. We said that as we move one place value to the left, it gets 10 times bigger. But in this case, when I look at Vin's number, we're going from the tens place to the hundreds place, and then we're also making one more jump now to the thousands. So this would be a jump by 10. This would be another jump by 10. So really, if I think about it, the 4 in the thousands place is 100 times bigger than the 4 in the tens place. So Vin is incorrect. The 4 in the thousands place is 100 times greater than the 4 in the tens place. Again, because we had to move 2 place values to the left, not just 1. Okay. You guys are doing great. 2 more. So this is kind of like taking it back to 3rd grade here. Describe 2 ways to find the area of the shaded rectangle. So if you guys, I know that at the end of the year, you probably were introduced to perimeter and area. And so we know that one way, I'm just going to put like a 1 right here for like the first method I guess we could use would be to count the squares. So when you count those individual shaded squares, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, and we like to write square units. But then there's another way you can do it. Step 2. You can multiply. Then in 3rd grade, you should have learned these terms. The length by the width. That multiplication problem looks like this. 1, 2, 3, 4 times 1, 2, 3. And we know, because hopefully we studied those multiplication facts in 3rd grade, that 4 times 3 is still 12 square units. You can see square abbreviated just like this. Units, so we still get the same answer. Okay, last one. Number 11. In 4,400, or sorry, whoa, you know what? This is a big number. And we're going to talk for just a moment about how mathematicians can read that number. So we're going to kind of take it back for a minute, back to a previous lesson where we were learning how to read and write numbers. So I'm going to rewrite this one. 400, let's see, it's 448, and then a comma, and 244. So fourth graders always try to read this number, and they do it very quickly. And we have to break it into something called two different periods. Kind of like, I don't know, if you watch sports, sometimes the games are broken up into different periods. Same thing with big numbers. Because our brains, they like to think in like an easy, simple way to name a number. So I guarantee if I put a box around this part of the number, pretty much everyone would be able to read it. So I'm breaking it up into this period and this period. I break them up into like 3 numbers. You see they're separated by that comma. So let's look at the first period here. Can we all agree that would be 244, right? 244. We could all do that. So now here's the tricky part. What about now adding in this period? So here's what I would do. I'm using my eraser. Cover that part in your brain. So now how would you read this one? If you saw that number written on a board somewhere, wouldn't you just say, that's 448, Mrs. Body? Right. But now we have to put it together. So keep in mind that the comma really says the word 1,000. So when you see this comma, your brain should pause for a moment and read the word 1,000. So let's try it. Easy number first. 448, 1,000, 244. 448,244. You got it. Now let's look back at the question and see what are they wanting us to do with this number. So we're looking at the value of the different sets of 4s. So in this number, how is the relationship between the first pair of 4s? So I'm looking at the first pair of 4s. I guess that's in that first box. How is the relationship between the first pair of 4s the same as the relationship between the second pair of 4s? Okay. So I'm going to rewrite this one. Again, remember, 448, that was easy. 1,000, 244. And I'm looking at these first pair of 4s and then these 4s. So what's the relationship? I guess what they're asking me is about the whole 10 times greater when we move place values. So we might say something like the value of the 4. No, which 4 are we talking about? So this is where it's kind of tricky. We're talking about this 4, right? It's 10 times greater than this 4, and then this 4 is 10 times greater than this 4. We know that. So the question is, how do we write this? This is tricky even for me. The value of the 4, let's say on the left, is 10 times greater than the value of the 4 on the right. Now, they were asking about both pairs, though, so I might finish this by saying in both pairs. Okay. Alright guys, so those were the questions. Hopefully this video helped. And I think that we may have to talk tomorrow about possibly having videos like this each day where we go through and I kind of model these questions for you, because we really are having a hard time with Teams and then this software. I want to try one more time tomorrow, but I hope that this video, I hope you were able to follow along. Thanks guys.